Having discussed the concept of multicollinearity, the causes of multicollinearity, the consequences of multicollinearity, etc., we will be looking into the test of multicollinearity in this video. So welcome back to Learn Economia. I'll be providing the links of all the videos which we have done on multicollinearity in the description box. So if you have not have an idea about the concept of multicollinearity, you can go through that and then you can come back to this video to see the different tests which you could be used to detect the problem of multicollinearity. We know that multicollinearity happens when you run a regression with several independent variables and some of your independent variables are correlated. In the regression analysis, if you go for R square, or when you go for R square in the model, this can be used to see whether your model is multicollinear or not, or whether your model suffers from the problem of multicollinearity or not. Okay. If you have very high R square in your model, then you have the problem of multicollinearity in your model. And also, if you go for a correlation matrix, you will be able to see which among your variables are highly correlated. And you can drop any of these variables and transform your model, and you can see that whether the transform model still faces the problem of multicollinearity. Then the tolerance limit and variance inflation factor would be giving you some idea with respect to whether your model has a problem of multicollinearity or not. That means that you have the option in several software packages. You can see that several software packages would be offering you these tests so that you can see that whether your tolerance ratio and the variance inflation factor will offer you some signs or indications of your model to have the problem of multicollinearity. More variance inflation factors shows the presence of multicollinearity. The inverse of VIF, it is known as the tolerance ratio, and that's all about variance inflation factor and tolerance limit. Then you can have several tests like the Farrar-Glauber test. Here, if you have your variables orthogonal, then there is no multicollinearity. Whereas if you have your variables as non-orthogonal, that means that you have some degree of multicollinearity in your model. You can also use a conditional number test. Here, if the figure you get is above 30, if it is above 30, that means that there is severe multicollinearity in your model. Multicollinearity could also be detected by using some random noise. If you could add the random noise to the data and rerunning your regression by several times, you can see that whether there is any change in your coefficients and see whether your model is having the problem of multicollinearity or not. So that's all about the tests which could be used for detecting the multicollinearity issue. That's all for today. Please like, share and subscribe to this channel for more videos and be a part of my Telegram group and Telegram channel to discuss your doubts. That's all about today. Thank you.